A CDN can reduce your latency by 10 times and handle millions of requests without ever touching your origin server. Here is how CDN architecture actually works. CDN architecture, high-level design, day 5. A content delivery network is a globally distributed network of servers that caches and serves content from locations close to your users. Here's the basic idea. Your origin server is in US East. A user in India makes a request. Without a CDN, the request travels all the way to the US and back. That is about 200 milliseconds of network latency alone. With a CDN, the content is cached on an edge server in Mumbai. The Indian user gets the response from the Mumbai edge server in about 10 milliseconds. That is a 20 times improvement. CDNs work by placing point-of-presence servers, called POPs, in data centers around the world. When a user makes a request, DNS routes them to the nearest POP. If the POP has the content cached, it serves it immediately. If not, it fetches from the origin, caches it, and serves it. All future requests for that content from nearby users get the cached version. There are two types of CDNs, push CDN and pull CDN. With a push CDN, you explicitly upload content to all edge nodes before anyone requests it. You control exactly what gets cached and when. This is best for static assets like JavaScript bundles, CSS files, and images. The content is pre-positioned, so the very first request is fast. The trade-off is higher storage costs because you are storing content on every edge node. With a pull CDN, the CDN fetches content on the first request. The first user experiences a cache miss. The CDN pulls the content from your origin server, caches it at the edge, and serves it. All subsequent requests get the cached version. This is better for dynamic content and API responses. The trade-off is a first request penalty. In the real world, most production systems use both. Push CDN for static assets like Netflix video chunks, pull CDN for dynamic content like Twitter timelines. Let me walk through the exact request flow. Step 1, DNS resolution. When a user types your domain, DNS resolves it to a CDN domain, not your origin. Step 2, anycast routing. The CDN uses anycast to route the request to the nearest point of presence. The same IP address is advertised from multiple locations, and the network routes to the closest one. Step 3, the edge server checks its cache. If the content is there and not expired, it serves it immediately. That is a cache hit. About 95% of requests in a well-configured CDN are cache hits. Step 4, on a cache miss, the edge server fetches from your origin, caches the response, and serves it. The cached version serves all future requests from that POP. The key insight is that only 5% of requests actually reach your origin server. The CDN absorbs the other 95%. CDN caching is controlled by HTTP cache control headers. For static assets like JavaScript, CSS, and images, set cache control to public with a max age of 1 year. These files are immutable because you version them in the URL. When you deploy new code, the URL changes, so the CDN fetches the new version. For dynamic API responses, use a shorter max age, like 60 seconds. The CDN caches the response for 1 minute, then fetches fresh data. For private user-specific data, set cache control to private, no store. This tells the CDN to never cache this response. Only the browser may cache it. For content that might change, use must revalidate with an etag header. The CDN checks with your origin if the content has changed before serving the cached version. Getting these headers right is the difference between a fast CDN and a broken one. 3 major CDN providers you should know. First, AWS CloudFront, deeply integrated with the AWS ecosystem, offers Lambda at edge for running compute at edge locations. Over 450 points of presence worldwide. Best choice if you are already on AWS. Second, Cloudflare, independent of any cloud provider, has a generous free tier, offers workers for edge compute, over 300 points of presence. DDoS protection is built in, best for cost and ease of setup. Third, Fastly, known for instant cache purging in about 150 milliseconds, uses VCL, a custom configuration language, for advanced routing logic. Used by GitHub, Stripe, and the New York Times. Best when you need instant cache invalidation and custom edge logic. In interviews, choose CloudFront if you are on AWS, Cloudflare for cost and DDoS protection, Fastly when instant purge and edge logic matter. Here is your interview framework for CDNs. When to use a CDN. For static assets like JavaScript, CSS, and images. For video and audio streaming, when your users are globally distributed. For high-traffic read-heavy content. When a CDN will not help. Real-time data like stock prices, because even a few seconds of caching is wrong. User-specific private data that should not be on a shared cache. Highly dynamic content that changes on every request. Single-region users where edge caching adds no benefit. The interview framework is 5 steps. First, identify static versus dynamic content. Second, static content goes to a push CDN with long TTLs. Third, dynamic content goes to a pull CDN with short TTLs. Fourth, set the right cache control headers. Fifth, plan your cache invalidation strategy. Use versioned URLs for static assets and purge APIs for dynamic content. The pro tip is to always mention a CDN when the system serves users globally. It shows you understand how to reduce latency at scale. 5 things to remember. A CDN serves content from edge locations near users, reducing latency by 10 times or more. Push CDN for static assets, pull CDN for dynamic content. Most systems use both. Cache control headers control what gets cached and for how long. Get them right. For invalidation, use versioned URLs for static assets and purge APIs for dynamic content. And always mention a CDN in your system design interview when the system has globally distributed users.